So here's combination circuits. What I've done here is combination circuit is a combination of series and parallel. It's not a pure series, it's not pure parallel. What we have to do is to solve the most nested or most varied part of the circuit first, and then redraw it. And that's where students get really messed up and try to shortcut. Here I've got a parallel circuit in series with a series circuit. So I can't solve this in the series law, right? And it's not a pure parallel, so I have to solve the parallel circuit first. So I've redrawn it with these two here for the equivalent of that. Really what I should have done is labeled this one R1, R2, and R3. So this would be R1, and this would be R2, R3. This would here be R1, 2, 1 to 3, yeah, all three. So what we're going to do is we're going to solve for our RT. And then we're going to find out our total current, and then we're going to fill in this as we go backwards using our parallel and series laws. So let's say this is 60 ohms, R3 is 60. Let's say R2 is 20. And let's say this is 45 ohms. So as we're going to solve our most nested one, which we can't solve series, but can we solve something in parallel? Yeah, so we're going to solve our parallel circuit. So we just solve these out here. That's 15 is equivalent to 20 and 60 parallel, 45, 60 ohms. And so let's take this one here. Let's say this is 120 volts. Which means our 120 volts is here. Just like our original single circuit, we have 120 volts. Across here, we can even, so now we can figure out what our amperage is or IT is. So 2 amps. 2. So now as we come out, we have to say, okay, I'm coming out to a series circuit. And what is the same in a series circuit? Current. So I'm going to take this 2 amps and put it out into here. That's the same series circuit. Now I can find my voltages across each one. Volts across this. Volts across this. Our source is still 120 volts. Kirchhoff's law states that any potential difference has to be shown in the circuit. So there's no missing voltages. Any potential rise would be a potential drop in the circuit. So 90 and 30 equals 120. Right back. So for this R1, nothing happens here, nothing changes. So this is going to still stay 90 volts and 2 amps. But now we take this, we're coming back out to a parallel circuit. What's the same in a parallel circuit? Voltages. So now we're going to transfer this voltage over. Both of these. So anything in parallel has the same voltage. Complicated circuits. Let's see. So now we can find our amperage in each one of those resistors. Wattage on there, 15 watts. 45 volts. Up here. could add up all of the combination circuit, all the wattages have to add up. So 180 plus 45 plus 15, is that 240? Yeah. Good. So I got one wattages right. I've got two voltages, 30 here. And so we can look at another one of Kirchhoff's laws, a known law. So I have 2 amps coming in. It's like I've got two cars coming into a intersection. And, so I've got 500 milli going this way. 1.5 is going that way. And then the same thing down here. Series law, 1.5 here, 1.5 there. 500 milliamps here. Coming out. So there's our circuit. So yeah, so we went all the way up to here. We came back, moved our current in here to the series circuit. Found 30 volts across here, and we brought our 30 volts from there in parallel, so same voltage. That and the resistance found the current from the wattage. Found the current node. Laws here, Kirchhoff's current nodes. Current into a node has to equal the current out to a node. So just coming in, coming out. All of our wattages add up, voltages add up. Okay, so down here, I've given you some values, and so what I'm asking you is maybe just redraw it here, where you can maybe solve this parallel and this parallel, and then maybe draw it again, and then we might have to prove one more, and then work our way back out. So, power. And then what would I solve next here if I was to redraw this? Okay, there's it solved really one step at a time, kind of under a pressure one. So now we can, once that's solved like that, I'll let you go through and do the calculations. Maybe some of them, but sure. Should do more of it. So yeah, so 10 and a 10 is 5 ohms, and a 10 and a 10 is 5 ohms here. So we've got series law, that's 10 for this branch here, 10 for that branch there. 10 and a 10 in parallel is 5. 5 and a 5 in series is 8. So now I took the voltage from here, put it there. So we get 12 amps. Coming out to a series circuit. 12. And so 12 times 5 is 16. 16 watts. I'll get back into the watts. So nothing changes between this one and this one. I think there's 60 volts in here. And what's the same in a parallel circuit? 60 volts here. 60 volts here. 6 amps here. 6 amps there. And we're coming out to 2 series circuits. Same in the series circuit. Series circuit is 6 amps. So 30 volts across here. This one has more imaginative, I've got maybe unbalanced, but. And this one here is still the same, 60 volts, of course, 12 amps. So coming back to here, this one stays the same, still has 6 amps, 3 volts. This one here, we've got a parallel circuit, so we bring our voltage out. Which one of these should be 3 amps, and down here has to be 6. That doesn't change. So what is the, I'm just marking 2 points. I could put a bunch of other points in here. Make this point C. This point D. This point E. So how about we just do what is the voltage A compared to B? This one thing we need to do is we need to polarize our circuit. So let's do that. This is going to be the negative bus, positive bus. When I say bus, I mean this whole thing where it's fed from. And so these are negative, positive, positive. So VAB, if I go up this way, I go positive 30 volts. Come down here, I got a negative 30 equals 0. And if I come down this way, let's go through this way, I've got a negative 30 volts. Come down here, come up, you see, come up, I can go positive 30 volts. Equals 0 volts, so there's no potential between those 2 points. Let's do one more here. Let's do voltage D to C. So we started D. Let's walk down this way. We'll walk down, we'll come across here, we've got a minus 30. Come down here, we've got another minus 30. This one. And now we've hit C right there, so minus 60. But let's go another way. Instead of walking down straight towards C, let's walk around through the power supply and back up to C. So we come down here, we got a negative 120. Here to a positive 60. And then we come back to C. So it gives us a minus 60 volts. So it doesn't matter which way you walk the circuit. Did I hear somebody say, you got any more of those? I'd like to do some at home today. I do actually. So it looks like it's about time for a break. I think my alarm will go off pretty soon, so I'm just gonna wrap up doing combination circuits there. Let's see if that's good practice for all the different flaws. Kirchhoff's laws and stuff, not Kirchhoff's good ideas, but Ohm's good idea. There's a relationship. Why don't we go take a stretch, 5 minutes, get some fresh air. What do you need to rejuvenate? Please look at your phone. Just look at WhatsApp, or Instagram. We'll come back. We'll do some